Welcome back to another NMRAx episode. Martin said in the previous one, I'm pulling my hair, but there's none left. So he already lost those in the previous NMRAx round. Our next presenter, with an update on photo interpretation for model makers, lives in Moncton, New Brunswick, and serves as AP Chair, a board member, and coordinator for the monthly third Thursday seminar series for the Eastern Canada Division of the Northeastern region. His primary modeling interest is centered on the Canadian National Railways, and he enjoys building rolling stock and structures from scratch and kits. He has been an NMRA member since 1997 and holds the still under warranty MMR number 720. Please welcome Mr. James Whatley.
Thank you for the introduction, Speed. Basically tonight I'm going to be talking on photo interpretation. This presentation is an update of one I did a year ago for NERX, and I've included a lot more material on some computer-based techniques that are fairly easy to do and hopefully will be useful to the audience. So here it goes. So in our travels, model makers frequently notice interesting subjects we would like to construct. Often, blueprints or published drawings simply do not exist. Working from photographs may be our only choice. This presentation covers some useful tips and methods to help you interpret photos for model making. Now, the field of programmetry, commonly referred to as photo interpretation, is defined by Wikipedia as the science and technology of obtaining reliable information about physical objects and the environment through the process of recording, measuring, and interpreting photographic images and patterns of electromagnetic radiant imagery and other phenomena. Wow, what a mouthful. Well, it turns out that this is a rather big field used by governments, military, surveying companies, you name it. But we're going to talk about some simple, easy to learn techniques that will help make our model making more enjoyable and extend our opportunities. So first I'm going to talk about the photograph. Photos may be ones you have taken or obtained from sources such as books, magazines, and especially the internet. However, not all photos are created equal. The image may be taken at an inconvenient angle. It may be poorly focused, taken in poor lighting, with shadows obscuring important detail, and or have poor exposure. The best photos for modeling are sharp, crisp images taken straight on in direct light with low image distortion caused by some wide-angle lenses. However, compromise is usually necessary. For example, we can't go back in time to rephotograph something that no longer exists. And also, fences or other physical obstructions may limit access even when we do have a contemporary subject. So what to do about that? First, I want to talk about the choice of cameras if we are taking the photos. So any camera will do, but certain ones are more suitable. Most cell phone cameras have very wide-angle lenses which are optimized for taking close-ups of people and may therefore introduce undesirable distortion in photographs intended to be measured for model making. However, cell phones do have their place if their limitations are understood. Digital single-lens reflex and older film SLR cameras are a better choice as they have a wide range of lenses available and feature convenient to use setting adjustments. Now, something very important when you're making a site visit to something that currently exists, it's really important to obtain permission from the property owner before entering on private property to take photos and measurements. And I found in most cases when you state clearly what you want to do and that you're a model maker and this is helping you in your research, people are sometimes quite enthusiastic about even helping you and offering relevant information. So obtain permission first. Now, the first example I'm going to show you is a model of a CNR wood chip car that I made years ago. And I was given a photograph by the late Frank Lemick, who is also an NMRA member, and he was a commercial photographer. And the photo I'm going to show you is an excellent example of a well-composed, well-exposed, straight-on, well-lit, and sharply focused photo, ideal for model making. So this is the print that he gave me. And Frank used a speed graphic camera, which could be adjusted to minimize perspective distortion. He also had considerable darkroom experience and accurately printed this picture in HO scale, allowing direct measurements. And indeed, I've put a HO scale ruler in the scan there. Although most of us lack this sort of experience, we now enjoy the benefit of many present-day computer-based photography solutions. So to scale a picture, Frank had to have known at least one actual dimension, such as the overall car body length. This information can also be inferred knowing certain standard part sizes such as door widths. Rebuilt cars like this one were converted from standard boxcar designs for which dimensions may also be known. So few tools are required to really get the information out of photos. So if you're 40 or more, you probably are already using an Optivisor. That's very familiar to practically most of the model railroaders I know. Next over is an architect scale, which has all kinds of different scales we commonly use. There's a similar one called an engineering scale, which has a lot of divisions based on powers of 10, which are very useful. Then there's a couple of sizes of dividers and a vernier caliper. Now, the dividers could even be something out of a $7 school geometry set. They don't have to be a fancy pair. And then next over is a machinist scale, an HO scale rule, and a protractor. So these are some of the basic things we need to take measurements from photos. So here's another view which might be typical of what might just be available, and maybe you don't have a square-on photo. So this end view of this car is taken in a traditional three-quarter view. So knowing the car height from the side view, comparative vertical measurements may be taken at any one vertical line using dividers or calipers. So if you can see the cursor here, if we consider the near corner to the camera, everything along that line can be measured in relative proportion to each other. But if we want to take a measurement of, say, the center of the car, we have a different problem because in perspective, there's a series of perspective lines radiating out to a vanishing point at the right along the top chord and along the end sill, and it goes to a vanishing point on the right. Similarly, there's a set of perspective lines receding over to a vanishing point on the left, coming along the bottom sill to the left and along the top chord to the left. So as we move further away from the center of the picture, all of the lines are proportionately reduced. So we can't directly make a comparison of a measurement taken on this corner with some other location. So that's what the effect of perspective does in this case. However, let's say that we know that the car body is 12 feet high from the top of this chord to the bottom of this end sill. So let's say we're interested in the height of the ladder and where it intersects the side. So let's say that we take our dividers and we take a measurement from here to here, and we take another measurement from the top chord down to the side sill, and we find that the top of the ladder is 0.75 or 3/4 of the overall side height. So if we know that the car is 12 feet high, we then know that the end plate or the top of the ladder would be 0.75 times 12 or 9 feet above the underframe. So we can take all the dimensions we want. We can even figure out the spacing of the ladder rungs, any other features we're interested in along this corner. Now, let's say we want to find the height of the brake step. And we can use a similar procedure, but we now must proportion our measurements on a line running through the brake step. So let's consider the left edge. So if we take the ratio of this point to the bottom and the car top to the bottom, we still know the car is 12 feet high, but the vertical line that we're using is now intersecting the brake step, so we'll get an accurate number. So you just have to be aware of the effect of proportion as it's changed with the perspective receding to the vanishing points. So here's the finished model that I built a long time ago from this 2 photographs actually was all I had. So now if we are actually going out to gather field measurements ourselves, assuming the structure or rolling stock still exists, it's really handy to have a number of things in advance. And you need a couple of pencils, some colored markers or pencils are good. I like to use a sharp, fine tip mechanical pencil, good eraser. You need a calculator. Clipboard is handy. This blue tape is a 100-foot tape, and the red one is a 16-footer. The 16-footer is handy when you're trying to measure smaller distances, especially things over your head, because to a certain extent the carpenter's tape there will be able to hold itself stiff for 3 or 4 feet above you. And I have a checklist of all the things that I usually need to take to site. So you don't want to get out there and find that you're missing something and you've partially wasted your trip. So in fact, I keep a case with everything I need ready to go. And the other thing that I have is a photo stick to graduate it 4-foot stick of wood. I'll talk more about that later. So the next project that I'm going to talk about is a model I made of a CN Yardman's shanty that used to live in Rockingham Yard in Halifax, Nova Scotia. And I took some photos during a vacation in Halifax in 1980. And then from the photos and a few field measurements, I made a drawing and then built an HO scale model. So this process doesn't have to be terribly elaborate. This picture is an example of one I took at the time. And if you think about the front of the building, everything is in the same plane except the roof. So I could take, if I knew the width of the building, I could proportionately scale off the width of the windows and the door and the spacing between the windows, even the size of the sign, and so on. If you knew the height of the boards, you can also figure out the height and check that against field dimensions you might have taken. So then what I did here is I made a very simple paper scale to match the photo, and then I can use that as a kind of a scale ruler that applies just to this photo. So that's a very, very old and simple method. So you don't need anything too complicated for this type of project. And sometimes we have angled pictures, and they're still useful to confirm detail placement and proportion. I'll talk more about that later. So here's the drawing done back in my pencil and paper days, and this is perfectly acceptable and useful for making a model. So here's the model I made, and I took some liberty to figure out what the interior would be like because the interior was pretty much gutted by the time I saw the building. But the exterior is fairly accurate to the prototype. A similar project, which was a little more involved, which I did a number of years ago, was to build a model of the Intercolonial Railway blacksmith shop in Moncton. This building actually still exists. Used to be owned by Canadian National Railways, and now it's privately owned. And I made a drawing using the same kind of methods I described earlier, and I was lucky enough to have it published in the CN Lines publication of the Canadian National Railway Historical Association. And this is the model I made. So I just want to show you that the methods work, and if you're patient and careful, you can produce a pretty accurate model. So photo enhancement software, which we all pretty much have access to now, is very, very helpful for this type of work. For historical subjects, we simply have to use the available existing pictures that may or may not be ideal for our purpose. Most digital cameras come with some basic editing software, and there's more sophisticated options such as Lightroom Classic and Photoshop and several others that have very useful features. For example, Photoshop includes a perspective removal tool called Perspective Warp that may be used to advantage to make angled prototype photos more useful for modeling. So do other programs include that feature. So a basic use of photo enhancement software could be just as simple as adjusting the exposure and contrast settings that will reveal more detail in a less than ideal photo. So this CNR caboose, or van as they are called in Canada, is kind of an underexposed, not that great photo, but I've spruced it up here and you can see a lot more of the detail. And keep in mind, we're not entering a photo contest here. We're just trying to get the information so we can make a model. Now this picture was of 3 old bunk cars I took in Moncton in 1973, and then later on when I went to make a model, it was the only photo I had of these cars. So what to do? So I started zooming in and making some basic image enhancements. You can see I've started lightening the image and drawing out the shadows. And I've also started increasing the exposure, and you can see how the ends are starting to appear. Like this ladder, which over here is almost hidden, is now visible. And you'd be amazed at what detail you can pull out of less than ideal photos using photo software. So figuring out dimensions in an angled picture in the receding perspective plane is tricky, but it's possible. For example, knowing the overall car body length and counting the vertical siding boards, in this case, helped me determine the window sizes and spacing. However, using the Photoshop Perspective Warp tool is also an effective, although multi-step process. So this is an example of how you could use Photoshop. So you basically open the photo and you place a grid over the portion of the image to be straightened. And it's very easy to do. You just place these dots right at the corners and you'll see a grid appear. And then you push and pull the grid until it's approximately parallel and rectangular. And you can see that the image looks squished, but the perspective has been removed. So then you have an export function in Photoshop, and you can export it in various formats. And in this case, I imported it into a computer-aided drafting program, or you could import into any other graphics software as long as it has accurate scaling capability. So in my case, I used DraftSite by Dassault Système. It's a very good AutoCAD compatible at a much, much cheaper price. I've been using it for 3 years and I use it a lot in model railroading. So in this case, we knew that the prototype car had a width of 36 feet. So I drew a box 36 feet or 432 inches wide. And I also put a scale on. And the next thing I did was I stretched the image until the width matched the width of the photo matched the 36-foot width of the box. And horizontal dimensions may be now measured directly right off the CAD drawing. And with more photo editing, I could have fixed the vertical dimensions as well, which I didn't show in this example. So here's the models I made. The first two on the left are scratch-built, homemade one-piece resin cast bodies with Tichy windows, microscope, slide cover glass. And the right is a kit by Brian Pate that I cut in with windows and also their Tichy. All the hardware is scratch-built except the trucks and smokestacks. So now a more complicated project that I took on a few years ago is to build a model of a preserve station called Apahawk. There's a little town about a third of the way between Moncton and St. John, New Brunswick called Apahawk, and it was on the main line of the CN between Moncton and St. John. And about 30 years ago, this station was moved to the New Brunswick Agricultural Museum in Sussex, and I obtained permission from the museum to measure it a few years ago. So in cases like this, where there is a structure that already exists, it's very handy to take photos in advance and return with printed copies so you can mark them up with your dimensions as you take them. This saves a lot of time compared with making sketches on site, and it's also less likely that you'll make an error. So that's an example of the front of the station that I've measured up. Now, when you're doing this, you can also include measurements right in your photos. And on the left is an ordinary measuring tape. I urge you to exercise caution to watch out for overhead power lines when extending metal tape measures, because it's very easy to get preoccupied with what you're doing and you kind of can forget your surroundings. But on the right is the photo stick again. And in archaeology, it's called a measuring rod. That's really where this comes from. In my case, it's a 4-foot piece of wood accurately graduated in 1-inch, 3-inch, and 6-inch increments. And it's much easier to read the details in enlargements of photos taken at a distance due to resolution limitations in your cameras. By the way, a friend of mine in Hamilton, Ontario, Ron Tuff, has an interesting variation on the photo stick. He took a wooden folding carpenter's rule and painted the alternating sections black and white, and he can just fold that right up and keep it in his camera bag. So it's kind of a neat thing to do. Now, when you're taking photos, it's very important to do whatever you can to minimize perspective distortion. So at the top photo, you can see the end window there taken with a wide angle lens, and you can see the distortion in the window. Particularly the top of the window appears narrower. If you look at the bottom photo, it was taken with a telephoto lens from quite a bit further away, and there's less perspective distortion. You can really see this if you look at the top photo, and the roof brackets there are obviously extending out to the left and the right because we're so close with a wide angle lens. And in the bottom photo, you can see that the roof brackets are more nearly parallel and extending towards the camera. Now, they're not perfectly parallel, but they're much better. And in both cases, you can see that I've put the photo stick in to help me scale anything I want in that plane. And on the right is a CAD drawing of that window based on the field measurements and interpreted measurements using the photo stick. Other useful techniques are to measure individual repeating features such as clapboards, bricks, and shingles and count the rows. So in this case, something I want to point out is counting rows of shingles will help determine the relative distance between the various roof features along the plane sloping away from the camera. However, a cautionary note here is that direct measurements taken along the roof slope are inaccurate due to the receding perspective because the roof surface isn't parallel to the camera's film plane. So we would need to have a photo taken at a 90-degree angle to get the full extent of the slope, and then go back and interpolate, for instance, where the toilet vent is, and so on. Other techniques are basically things you can confirm using standard features such as door sizes and window sizes. However, be very careful about assumptions, as dimensions vary, and there's variation in dimensions between commercial and private buildings as well. Now, for measuring roofs, I use, for small low buildings, and especially where I have permission to be there, I've used a simple method called what I call the weighted string. So what you do is you have a spool of string, household string, with a small lead weight, like a fishing weight, and you unroll quite a bit of string and you zigzag it in front of you, and then you throw the weight over the roof, and then you pull the weight back and adjust it to be parallel with the roof, and you in fact bring the weight or plumb bob so that it's just touching the ground on the far side, and you make a knot on the near side. It's also an extremely good idea to take a look at where any windows are before you do this, in case you throw it wrong. And so then you take the string off the roof and you lay it out straight on the ground, and you measure the total string length, and make note of that. So to summarize, you unroll lots of string and zigzag it on the ground in reverse length with the weighted end outwards. Throw the weight over the roof and align it parallel with the shingles. Pull the weight back until it touches the ground with the string dangling vertically like a plumb bob. Locate the spool end of the string on the near side until it just touches the ground vertically below the roof edge, and mark the spool end of the string and measure the whole length of the string. So what do you do now? So a fairly easy calculation is to basically recognize that the total string length is twice the eaves height and twice the roof slope for a simple building like this. So if you write this out, total string length is twice the eaves height plus twice the roof slope, and you rearrange it and solve for roof slope, you find out that the roof slope is the total string length minus twice the eaves height divided by 2. And presumably the eaves are low enough to the ground that you can take a direct measurement with your carpenter's type measuring tape. So basically, to summarize, the string length spanned the whole roof and twice the roof height at the eaves. We measure the roof height of the eaves. We subtract twice that amount from the total string length. The remaining string length is twice the roof slope distance. So dividing that by 2 gives you the distance along one roof slope. Now, as an example, let's say the total string length was 70 feet and the eaves height was 10. We'd end up with a roof slope of 25 feet, which is quite plausible in that case. There's another method in case you can't make a clean throw over the building, and actually my wife, Annette Fougere, came up with this, and you basically only throw it just over the peak and pull it back to the peak, and the calculation is simpler, and it basically means that the roof slope is the total string length minus the eaves height. You could use this all the time. I find there's a slight advantage in throwing the thing over the whole roof, because then any slight differences will be averaged out. But basically, I've used this method quite a bit too, and there you go. So when you can't get a clean throw, or there's a tree behind the building or some other thing like that, throw the weighted string, but pull the weight back just to the roof peak, again keeping the spool end vertical where it touches the ground. Measure the total string length, subtract the roof height at the soffit, and the remaining string length equals the roof slope distance. Now there's another method when you can't use the string method or it's not practical. You can do this with a bit of trigonometry. Now, if you happen to be a surveyor, or you know somebody who is a surveyor and they have a surveying theodolite, you can get very accurate results by shooting lines to the top of the building and taking a reference angle to the ground. But for our purposes in the hobby, adequate results are possible by sighting along a protractor placed on top of a leveled stool at some known distance from the building. So if you recall your high school trigonometry, the height is the distance from the point where the angle is measured times the tangent of theta. And we know that the tangent is opposite over adjacent. So basically, if the angle we measured with our protractor was 20 degrees and the distance away was 200 feet, the height would be 72.8 feet. So that would be a multi-story building or something like that, a bridge, anything we want to measure. So here's the completed drawing I made of the Apahawk station. And fortunately, the museum opened the station, and therefore the interior partitions and everything could be measured as well. So it's very lucky to get that kind of cooperation. And here's the finished model I made. So I leave it up to you whether I captured the prototype correctly or not. Another technique that is extremely helpful is the photo underlay technique. I don't know if there's an official name for this, but that's what I call it. So assuming the availability of good square-on pictures, another useful photo interpretation technique involves importing a picture into a layer of a CAD program, such as DraftSight or any other CAD program, and the subject is then traced out in another layer. This is equivalent to using a suitably rescaled photo under tracing paper. Now, you could go to a photocopier and fix up your photos and go ahead and do it entirely with pencil and paper. I find using computer techniques allows you a lot more freedom in and flexibility in how to do this and get good results. It's very important. You still need to watch out for picture distortion, and this method is especially useful when a complete set of field measurements can't be obtained, which is quite often the case. So as an example, I'm going to use the photo underlay procedure applied to the Kokan, New Brunswick range front lighthouse, which I'm currently building a model of. And so starting with a set of basic field measurements, as you see here, an outline of the structure is drawn in the CAD program working layer, as you see on the right. And we need to know at least something about the real building, such as the base width and the slope of the sides. So if we know that, we can then take a photo and import it into another layer of the CAD program, in this case, using the attach image command. Now, the photo must have been taken as square on as possible, preferably using a telephoto lens from a few hundred feet away. Now, the real lighthouse is about 26 feet high, and ideally, it would have been nice to have been on a ladder with the center of the camera about 13 feet above the ground. But that wasn't entirely possible. However, as I went further and further away from the building, the land sloped upwards a little bit, so I did get some elevation to use to advantage. And I also took about 10 images to get the one that was the most vertical, as I did not have a tripod with me. Now, some cameras include a level feature, which is very useful to have. So basically, this is the best I could do with what I had available. So I imported it into the CAD program, and if you look here, you can see where I started drawing in the outline and a little bit more than the outline. And I also put in a center line in the CAD program drawing, this cyan colored line. And that's very important to keep everything symmetrical. So in this case, I used a different technique to adjust the image size. So I first, after I imported the photo, I measured the width that the CAD program thought the photo was using the get distance command to get, in this case, the width of the base. So I'll call that X. And then I calculated a scale factor, which is the actual known building measurement that I took on site divided by measurement X. So let's say that the real building was 20 feet wide, but the measurement on your CAD program said 10 feet. So your scale factor would be 20 divided by 10, or 2. So you then call up the scale command, and it takes you through some prompts, and you enter the calculated scale factor and press the button, and the photo is rescaled. And then you recheck it using the get distance command again to make sure that it really is scaled properly. And this is an incredibly accurate method. Now, once you get the photo fixed up, you start tracing in the details over the correctly rescaled image. But notice that there's still a little bit of picture distortion at the very top. So that vent is kind of receding away from the camera, and it's going a little bit to the right. And even though the lower parts of the photo, as I checked them, were still good. So this is where the center line comes in. So what we're going to do is we're going to average out these measurements to make the actual final drawing symmetrical. And another tip is that when you're measuring or calculating roof slopes, or you're measuring them directly, you'll find that carpenters from the time 0 have always used some even number for the angle of the slope, like 30 degrees, 45, 60, and so on. If you come up with some number like 27 3/8 of a degree, chances are your measurements aren't 100%. So in this case, I can clearly see it's 30 by measuring directly off the photo. And you'll find, surprisingly enough, that those kinds of observations are typical. And you can also do some interesting things, like the door had a maple leaf painted on it. So you can bring that into the CAD program on another photo. And there's a tool called the polyline tool, and you can basically trace out an image of some arbitrary shape by placing dots over all the points of interest on the image. And you can fix up reasonable photo distortion with reference to the center line. For example, notice at the top left that I've pulled the dots in a little bit to make the top of the maple leaf symmetrical. And you can in fact see in the lower right here that the final image is quite symmetrical. And as a matter of fact, this method is used often by people who create artwork for decals. And there's all kinds of programs for doing that. A friend of mine uses Inkscape. Other people may use CorelDRAW. There's all kinds of software for that. So here's one view of the final drawing. And basically, this happens to be the east elevation. I've determined by checking that the resulting drawing accuracy available using the photo underlay method is actually within about 5% of true size, which is pretty darn good for a model purpose. And in comparison, you can get about 1% accuracy if a complete set of field measurements is available. So either one of these methods is very helpful. So in conclusion, I recommend that you make a photo stick. I encourage you to prepare a checklist of all the tools and measurement aids you will need before traveling to the site. Take clear, well-lit, well-focused, square-on photographs from as far back as reasonable to minimize distortion. If feasible, bring pre-printed pictures to site to mark up with dimensions. Think creatively about how to use building features, for example, counting boards, bricks, and shingles. Use photo software to enhance less than ideal historical pictures. Using CAD software adds flexibility and accuracy in what can be accomplished. And please do consider using the photo underlay method, especially when obtaining complete set of measurements isn't feasible. So just go out and get started. And I have some resources here. If later on you want to play this back and pause, you can see I've included the drafting program I use, Photoshop, Lightroom Classic. There's a couple of other photo programs that friends use. I have not used them, but they come highly recommended. One is Affinity Photo 2, and the other is Photoscape X. So there you go. So as Porky Pig would say, that's all, folks. Are there any questions?
Oops, I pulled a Martin. I was muted. I just want to update that also add to your list of um, resources there that your previous clinic was on March 23rd, the fourth day of NRAx last year. It was the first clinic of the day. So people want to use YouTube and find NRAx in our live group of clinics. They can see your first one. On to the questions. So, would you please comment a little more on the software you're using and the cost of it?
Sure. So for the drafting program, DraftSite was recommended by a friend of mine who's a mechanical engineer, and he actually used it professionally in the aviation industry for many years. And one of the things it's got going for it is it's much, much cheaper than AutoCAD. AutoCAD's kind of the de facto standard in the industry. But my version of DraftSite is the basic version, which originally was about $99 US, and now it's gone up. My annual renewal is something like 172 Canadian. So anyway, they now want you to take the professional version, which I believe is 299 US a year. But some people may balk at that and think, wow, that's a lot of money. But people frequently pay a lot more than that for the latest locomotive with DCC in it. And I've used this software for many projects for the past 3 years. So, it ends up being a very valuable tool. As far as the photo software goes, I have another hobby of mine, which is sort of tied in with model railroading, is photography. So I chose to take a subscription to Lightroom and Photoshop. I recommend Lightroom Classic if you want to keep the program on your computer. Otherwise, they offer a cloud version. But it turns out that if you also want to save the images on your local storage, you can get a much cheaper price by digging through their website, and you can find um, a good price. I'm paying $12.99 Canadian, which I think is a bit less than $10 US, and plus tax. And the one with 20 gigabytes of cloud storage is something like double the price. So, it's still something you pay for. But the programs that I recommended there, Affinity and Photoscape X, are either much cheaper or free, and they do have many of the same attributes. So it pays to talk about this with your friends, and especially people into photography, and see what you can find.
So, do you have to upload your photos, or when you take the picture, it uploads itself?
I I can upload directly from the camera to my own computer, and it then allows me to put archival information on there, such as keywords and other
Okay.
things. It's quite useful.
And you said it was called Lightroom?
Lightroom, yes.
Lightroom.
I use Lightroom Classic, which is the older version that runs on the computer locally.
Okay. So I only have a cell phone camera. Can I still use it to take overall shots of buildings and rolling stock?
Yes, you can. Now, notwithstanding the points I made about the wide angle lens issues, what most cell phone cameras, if you dig into the settings, you can increase the resolution quite a bit. Many of them are set for sort of mid-range setting resolutions so that you can email photos and not consume huge amounts of bandwidth. Basically, most cell phone cameras do have resolution adjustments. So the higher the better for this particular task. And then you would still want to go away, back up as far as you can if that's possible, and then zoom in with the camera and try your best. I use the cell phone too, but if I'm on an actual job where I know that I'm going somewhere to make measurements, I'll take my SLR camera.
Okay.
But many people today now have cell phone cameras, and in fact, there are third-party attachment lenses you can get to change the properties of the
Hmm.
built-in lens.
Now, do you set your SLR camera also to the highest quality?
Yes, because when you're zooming in, you may actually end up working with only a very small portion of the overall image. So the more pixels you have, the better. That's a good question, Speed. More
Cool.
pixels is good when you're going over pictures with a fine-tooth comb.
So you mentioned at some point about the kind of even numbers that they use, like 30 degrees or 40 degrees. Would it be wrong to model something that's at 32 and a half degrees?
No, and certainly you can't, the minute you say, well, roofs are only on in certain multiples of angles, people will be coming forward and there'll be thousands of comments. My roof is not like that. But the fact is that I was told this information actually by a retired builder who said that in days past, carpenters had carpenters squares with certain rules of thumb marked on them, and
Uh-huh.
and nobody goes out of their way to make their job more difficult than it has to be. And through time, they also know how rain sheds from roofs and snow sheds from roofs, and so kind of standard rules of thumb evolved.
Yes. Yes.
And once you start, the funny thing about doing this kind of site visit and measuring is you hear about these kind of rules of thumb, but you start to see them as you're doing your research. It's a fun part of the job.
And when you mention that to some family member, then you sound like a professional, right?
Well, they all know that we're on the eccentric scale as it is.
Yeah.
So
What if all you have is historical photos, all black and white photos? How would you use those if you can?
same way, for example, I've taken photos out of the old car builder cyclopedias and I've scanned them in the computer. And again, you need to know something about the subject of the photo. Like, for example, the wheelbase of the truck or the length of the car body. Like, if it's a 40-foot, 6-inch box car, that kind of information is really good. Now, it just so happens that a lot of those old photographs, like car builder cyclopedia photographs, were professionally taken by professional photographers. So they were kind of natural for what
Hmm.
we need. And then another really good source is old postcards that you can get at flea markets and things. And um, you've got to be creative. The further away the image is in the picture, and the smaller the actual area to work with, you may have to wing it a bit to get some dimensions. But if your doorway is coming out at 5 feet, probably that's not right. 6'6" would be probably better. 9 or 10 feet for a story, things like that.
Hmm.
So just use common sense and give it a sanity check. When you finished your sketch or drawing, Uh, just does it look like the real thing, or does it look kind of squashed or too narrow? Or
Correct.
and don't be afraid to keep adjusting it within reason.
Did you ever come across the whole selective compression thing where we can't show all 9 windows because we don't have enough space for 9 windows, and then your photos don't align with that?
Yes, and what you have to do in that kind of a situation is you kind of have to look at the building, the real building, and say, what's a real typical characteristic of this building? Like if somebody was driving by in the car, oh, I know that building. Well, what is it that they know about that building? Is it because it has some interesting clapboards? Is it because it has some interesting ventilators on the roof? Is it because it has a certain repeating pattern of windows? So try to see what it is about that building that catches your eye. And then whatever that is should be the basis for your compression.
Compression.
So I've seen cases where modelers have had a building with, say, 9 windows and they've built it with 6. And they've still created the impression that it's for instance, a shed or railway warehouse or something where it's a long building and it has repeating windows. It just doesn't have all the repeating windows. So you kind of have to do that. It's the same with locomotive models, especially steam locomotives. Like railroads had a family appearance, and if you kind of see what that family appearance is, you could almost get away with putting those details on a block of wood, and people would say, "Oh, that's a Great Northern engine because it's got green on it, and it looks nice." So
Yeah. So I have a reduced building here that I got from somewhere where someone decided, oh, we're not going to do 4 bays out to the rail side. We're going to only do 2 bays. But on the back side of the building, there's no doors because the doors were on the far right hand side where they cut those extra 2 doors out. So there's no way to get into the building except for showing up in a boxcar and getting on the platform. So
yeah, well,
I was
that's
like,
where you got to kind of say maybe it pays to go to sleep on it and come up in the morning and you say, then I'll do my sanity check.
yes.
And we
Okay.
all have the ability to redo something. I mean, don't get into the habit of saying, well, I've done it, we're done, that's it. Be critical of your own work.
Correct. Okay, last question. Can you go over the reason again to include a photo stick instead of a measuring tape?
Yes, basically the graduations on the photo stick are larger to start with. The smallest I use is 1 inch, and then 3, 6, and 12. And the alternating segments are black or white. So in a enlarged photo, you can get a nice crisp edge. Now, if you think about the measuring tape in the example I showed, it has 16ths on it, like a typical carpenter's tape. And by the time you enlarge that in a photo, it's going to start to get blurry. There's not a lot of contrast on the tape to see the edges. It's just, I found it's harder. And it's a lot easier to say, you know, I'm halfway through a 3 inch section, so it must be 1.5 inches from the edge. It's once you get used to it, it's very easy.
Well, thank you for a very, very insightful update. Um, we appreciate it, and I'm certain that a lot of people are going to watch this again.
Well, thank you very much for inviting me, and I hope the rest of the evening goes very well.
Thank you, sir.